All right, so today we're going to take a look at functions, and we're going to talk about their four representations. This is not going to feel like a traditional math class. Let me just tell you that right now. A lot of what we do in this class is interpretation and application to business context. If you just went through a traditional calculus class, you would not feel like there was absolutely any relevance to what you do, and this course is super relevant to business. So as you're looking through it and you're like, that don't look like any math class I've ever had, that's probably true. So, but it is absolutely meant to be useful to you in the future. So, first, there are four representations of change, how something changes. One is a numerical representation. When things are represented numerically, you're given that information in a table. We're going to see a lot of tables in class this year. You're very familiar with things being represented algebraically. Algebraically means that something is given to you as an equation. We'll use a lot of equations too, but mostly we'll be creating them, not be given them. The third representation of change is verbally. Something is described. There are components of your homework that will use a lot of verbal descriptions. If you're in a business context, nobody gives you an equation and says solve something. There's a description and there's a concrete word problem that you've got to figure something out to do with. Graphically is the one we will be using the least. It will come up. We will talk about it. We will create these things. Graphs are really helpful for those of us who are visually oriented, which is me. Maybe some of you too. So we'll use them, but we won't use them as heavily as the equations, the numerical and verbal. Okay, am I good to switch slides? Okay. You'll have less writing when I have when you get your printouts, but I'm sorry about that. A few vocab kind of things so that we're all talking about the same thing when we say those same words. A relation links one variable to another, just like a relationship would link two people, right? Relation links one variable to another. When we talk about input, input is the variable that we put into an equation. We use X a lot as our inputs. The output is the variable that comes out of an equation. And we use Y a lot for that. You will find that we use some other things as well in this class. And a function is a very special type of relation where each input corresponds to exactly one output. Am I good to switch slides? A couple more people still writing. All right, so one of the things I said just a moment ago was that output, we use Y a lot. We also use special types of output when we have functions, and we use a function notation often to distinguish that as specifically being an equation that represents a function. F of x, so it's the F, it's a parenthesis x, and we read it as f of x. It does not mean f times x at all. What it means is that x is the input and that f of x is the output. We often sort of relate that f of x notation to what we previously would have thought of as y. So on a graph, we might think of the x-axis and the y-axis. Well, the y-axis would be the f of x axis when we're dealing with a function specifically. One of the things you'll see in this class is a huge emphasis on units and interpretation. A unit of measure is a word or short phrase telling how a variable is being measured. For example, your input could be years. But what does it mean? Is it the year 2020? Is it the number 20 because it represents the number of years since the year 2000? Well, I don't know unless you tell me. I don't know how you have decided to determine it. So units are really important for us because they give the viewer, whoever's looking at your work, so for now, that's me or the grader, but in real life, that's your boss or your client, information about what it is you're actually telling them. Units of measure. All right, so we're going to do an example, because that was a lot of just writing. So I'll give you a chance to write this information down. I'll read it to you, of course, and then we'll do several questions related to this problem. A student's raw score on a spelling test with 20 evenly weighted questions can be expressed by G of n equals 5n when she spells n words correctly. Okay, so think with me a moment. If she gets all 20 questions right, what does it say her score is? 100, right? 5 times 20, right, is 100. Are you with me? If she only gets 14 questions right, we would say 5 times 14, and we'd find out her score that way. So this is an equation where you plug in the number of words she gets right, and you get out from that her score on the test. This says to identify the relation as numerical. Remember, numerical meant you were given a table. Algebraic means you're given an equation. Verbal, which means you're only given language descriptions. Or graphical, which means you're given a graph. What is this one? It's algebraic, right? It's got some words with it, but when it's verbal, it means it's only words. So this one's algebraic because they actually gave us an equation. This is an algebraic description. Or relation, sorry. Algebraic relation. So our next question then is, we now have an algebraic relation. We're going to identify the word, the question at the top is exactly the same, just the parts are changing underneath part B. So please don't rewrite the part at the top. That would be, yeah, don't do that. It wants us to state the description and units of measure for the input and the output variables. Okay? So what is the letter that's being used for the input? N. Yeah. So the first thing is we're going to write down that the input is N. And what does it represent? Describe it. Right. It's the number or how many. That's a pounds. That's not a hashtag. Just clarification. That's a number sign. Number of words spelled correctly. Not just spelled, notice. Number of words spelled correctly. That's my input. So what is the output first, the variable? Yeah, it's G of n. Not just G, but G of n. That is my output. And what in the world does the G of n represent? Yeah, it's the score on the test or quiz or whatever it is. It says student's raw score on a spelling test. So we'll write it out exactly like they did. Okay. So far, you have not written a single number on your paper. Well, you wrote the equation, it had a 5 in it. But other than that, right? Lots of language, crazy stuff. Next one. Top stays the same, question number C. Indicate whether the relation is a function or not. Okay, so again, function means for one input, you get only one output. Did you have a question? Okay. Is this a function? It is. You can think about it from an equation standpoint. If I put in n equal to 1, do I get one answer or two answer? 1. If I put in n equal to 2, do I get one answer or two answer? 1. And we can continue on and think through it like that. There's no way with this equation to put in a value and get two answers. Not true of all equations, by the way, but it's not true of this one. You can't do that here. So this one's a function because each number inputted, there's lots of ways you could say this, but will yield only one raw score. Each input has only one output. Each number of words spelled right gives me only one score. Lots of things we could say that are equivalent to this and all correct. The last thing we're going to do on this problem is to draw a diagram. Okay, everybody good? Okay. All right, so this one actually says indicate if the relation is a function. Sorry, that shouldn't say indicate. That is not supposed to be there. It should just say if. If the relation is a function, draw an input-output diagram. If it's not a function, explain why not. Well, we decided on the previous part of the problem it's a function. So I'm going to draw with you a diagram for an input-output. So you're going to draw what looks basically like a box with sort of an open area at the top and an open area at the bottom. The open area at the top is what's coming into the function. It's n. And somewhere up there you need to tell what it is. So this is the number of correctly spelled words. Well, what comes out, well, what does it go into? Well, it goes into a function who has a name, and the rule's name is rule G. It's just what it's called. So in the middle, you're always going to write rule, whatever the function's name is. Rule G, rule F, rule K, whatever. And then the output over here is G of n. And a descriptive phrase there, too, is that this is the raw score. So that's how input-output diagrams always look, okay? Only the letters and descriptions are changed to protect the innocent. Just going to adjust it every single time, okay? All right, so let's look at a little bit different kinds of questions that you can have and we'll see in this section besides that one that had a lot of verbiage to it. We will see some questions that are a bit more what you're used to seeing in an algebra course, okay? You're welcome to use your calculator. I am not teaching you algebra. I mean, we'll encounter it from time to time, but that's not our goal in this class. So I don't expect to see a whole lot of work. Your calculator can be used in large part to work through these problems. So on this question, we have an equation. It's g of x equals 7x squared minus 2x minus 3. And it wants you to find what happens when the it wants you to find, the output value when x is equal to 3, negative 3. So what it's telling you is that all of these x's here are going to become -3. Bare minimum, what do you need to show me? You need to show me g of -3 equals and an answer. That's the bare minimum. If you wish, you can tell me g of -3 equals, and you can show me all where the negatives are plugged in, or the -3s are plugged in. But if you simply want to put it into your calculator, that's okay too. So you're going to input -3 in for every single x value. And when you do so, and you simplify, what do you get? Feel free and grab a calculator if you want to. No problem at all on that. Say it louder. You're right, it's 66. The answer is 66. So we're doing this now on a pretty straightforward, just here's an equation, boom, do something. But we'll be doing it with content and context and information all surrounding it later too. What does that mean? What did we find? Now what? But for right now, it's just a matter of how do we do the problem mechanically. We can do the other one as well. This one asks the question a little bit differently. It actually asks you to find the input value when g of x equals 2. Well, they're actually telling you that the g of x over here, all of this, everything, not just the x, but everything is actually 2. So on this problem, you have 2, and it equals 7x squared minus 2x minus 3. All right, so if you were in a college algebra class last semester, you definitely would have moved the 2 to the other side and quadratic formulated it or factored it or something like that, right? That's what you would do if you were doing this with algebra, and that is totally fine, and you can do that if that is what you so desire. But I'd like to show you another way to do that if you have your calculator with you. If you don't, just kind of try to take some notes off the descriptions of what I'm saying so that when you have it, you'll be able to do it. The first thing I need you to do in your calculator, if it's not already set up, find mine in fact too, is I'd like for you to go into the table. That's not true. The table set. So that is, if you're doing this in your calculator, the table set feature, whoops, I'm going to write this in a different color. You get that by hitting the second button and then the window button. Okay? You'll need this later on, so we're just going to change it right now. When you do that, what you're going to see at the screen is it says table setup. Table start equals a number. It's got a little triangle, TBL equals a number. And then it says independent auto ask, dependent auto ask. Does anyone not have that screen pulled up if you've got it with you today? Okay, what matters is that the independent variable says ask, and the dependent variable says auto. Okay? So we're going to take a step back and take a look at problem A, part A for this problem, which is what's going to use this so you can see it. If you hit y equals and put your equation in, okay, so put the equation in y equals, and then you actually go into the table. So your table is second graph. What you'll actually see, if you just set it up for the first time, is an X in the first column header, a Y1 in the second column header, and then there's nothing underneath. If you already had it set up this way before, there might be some text and some stuff inside of there already. But all you have to do inside of there now, if you want to find out the answer to part A, is type the number -3. And your calculator will do for you what you just did by hand on part A. It will take the number 3, and it will plug it in for all the x's, and it will spit out the y value, or in this case, a g of x value for what you had. Cool stuff, right? All right. So now that we have the y equals set up, in y2, so hit y equals again, and then down in y2, what we want is we want our function to equal the number 2. So we have this in y1, and we're going to put the number 2 in y2. We're going to play with our screen and where we are looking on our screen a lot this semester. In order for us to both right now, or all of us right now, to see the same screens, if you just would hit zoom standard, which puts it in a -10 to 10 and a -10 to 10 window, it's just the standard window, then we'll all have the same window. So if you hit zoom, where is it? 6. All right, so let me show you what the picture looks like on my screen. So those of you who don't have one have an idea. And then those of you who do have one, you can compare. That's a messy sketch, but it looks something like that. Does yours look like that if you have it in there? Good. So let me just tell you, visually speaking, I'm a visual person, where the answer to the question that we're asking is. It's right here. These corners where they intersect. At those 2 dots, the y value is 2. How do I know? Because this horizontal line is 2, because that's what I told it to put in over here. So the horizontal line is at y equal to 2, so those 2 dots are at y equal to 2. The x value at those 2 dots is the answer to question B. So how do I find it? Well, there's this wonderful tool inside your calculator that allows you to scroll around. You can shift and do that. You get close, but it won't be as precise. There's another really cool, better feature that says, hey, find the intersection for me. Who wants that one? Me. So how do you find it? Well, you find the intersection by hitting second trace. It brings up the calc menu. For those of you who don't have a calculator with you and you're trying to take some notes over what I'm saying, this might be one of those videos you want to go back and watch these parts of that are telling you how to do all the cool calculator features once you have that calculator with you, okay? And do you see one underneath that calculate menu that says intersect? Nod your head if you have one of those. Okay, good. It's option number 5. Select option number 5. You can either hit the number 5, like just press it, or you can arrow down and select it, either way. On your screen, at the bottom of your screen, I wish I had a way to project my calculator, but that thing won't work, and the actual screen. On the bottom, it says first curve. You can just press enter. It says second curve. You can just press enter. And it says guess, and you just need to get close to one of those dots, those yellow dots that I marked up here, and press enter, and it will spit out at you an ordered pair. X equals this, Y equals this. The Y will equal 2. When you do this, the X value for the first one I found, because there's going to be 2 of them, is negative 0.714. And you can do it again. You can hit second, trace, number 5, first curve enter, second curve enter, and then scroll over to the one that I didn't get the first time for the guess, press enter. And it tells me the other one is x equal 1. There's 2 answers. That's a whole lot of technology, and if you haven't seen any of that before, you're probably going to have to play with that a few times through some problems before you get the hang of it and it becomes natural to you. But give me 2 weeks and you'll be doing it like you're doing your sleep, because we do it all the time. All the time. Okay, so it's a learning curve. You're going to be okay. Just keep trying and practicing with it over and over again. We have one more question to do today, okay? So we're almost done. Ready? Is everybody good on the screen for me to move along. Awesome. So this is an example of a verbally described situation. It says P of M is the median sale price in thousands of dollars of existing one-family homes in an area M in 2008. Okay? So notice what they said. P of M is a sale price, and M is an area. Right? It's an area. It's Oklahoma City. It's Shawnee. It's, on part A, Honolulu. It's an area. That's what M is. It's not even a number at all this time. That's okay. But the output better be a number because it's supposed to be a sale price. Right? So on part A, it says, write a function notation for the median sale price in Honolulu that's $295,000 in 2008. Now, the 2008 isn't irrelevant, but it plays no part in creating what I'm going to write down. It's just fixating a specific point in time because it would be different if it were 2020. Does that make sense? So, remember, function notation looks something like this. F of x equals an equation or equals something, some value. So we need our function name. What was it here? What letter? P. We need to know what is M in this case. The area. And what area is it on part A? Honolulu. So this is P of Honolulu. Equals, and in this case, it says the output is the sale price. And what is the sale price here? It is $295,000. I'm so glad you said it that way too. Do you notice there's this one weird thing that we haven't really talked about here? It says in thousands of dollars. What that means is that when I write the answer here, I only write the 295 because 295 is $295,000 because of what was said in that parentheses. That's what it means. That's the units on the problem. So not only can we be given a verbal description and told to put it into a function notation like we just were, we can also go the other direction. We can be told the function notation and we can be asked to put it into a verbal description. So this one says to interpret with a sentence, P of Rhode Island equals 137.8. Well, it better look an awful lot like what they said here because it's just taking the question and flipping it around, right? So we should be able to mimic the structure of that sentence on our sentence. The median sale price, well, that part stays the same, so we can simply write it. It is a sentence, so we probably should start with a capital letter. The median sale price. The next part of this says, in Honolulu. What's ours going to say? In Rhode Island. This one said was $295,000 in 2008. Ours on part B was what? Thank you. Yeah. 137,800. We do need a dollar sign, right? Just like the last one had a dollar sign when it was given. 137,800. What else do I still need? In 2008. Yes. In 2008. We're grounding our information by pinpointing a specific point in time. Okay. So usually when I get to the end of this lesson, people are like, well, wait a minute, what's my homework going to look like? Like the problems we just did. You're going to be interpreting language. You're going to be interpreting equations. You're going to be using the technology stuff. It's kind of an intro to the technology stuff that I did on that last problem, so that you have some of those problems to do. So you have practice problems. They may still say group work problems in the notes that are uploaded. I don't care what they say, but they're the first ones listed. My notes are old, but they say mine says group work. It has 4 or 5 problems, something like that. You'll start with that, and then you move on to the problems underneath. If you encounter some difficulties that you need help with, please schedule a time, come see me. We'll work through things. We will do a couple of problems at the beginning of class, but if you have more than a couple, you need to be seeking some help before you show up to class that day, okay? I will see you guys all on Thursday.